Hey my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. In this video, we are going to discuss about calculation of inputs for a given output expression. Yes, without any delay, let's enter into the question. The circuit shown below used to be used to implement the function z is equals to f of a comma b is equals to a bar plus b. What are the values of I and j? This is the given design. They have given the output expression and we want to determine these I and j values as per this Boolean function. So I repeat, z is equals to a bar plus b. Guys, here if you take this OR gate, the output term will be a plus I. Similarly here, a bar plus j. Now, the actual expression for this AND gate, z is equals to a plus I into a bar plus j, isn't it? Yes. Now guys, you compare both the expressions. This is the obtained expression and this is the required expression. How you can get it the same? Whenever I is equals to 1. So that anything plus 1, 1 only, 1 into anything, anything only. Moreover here a bar plus b na. So in place of j, b is required. Hence you can say j is equals to b. By substituting these I is equals to 1, j is equals to b in this expression, the expression will be like a plus 1 into a bar plus b. Therefore guys, the final expression is a bar plus b. Hence LHS RHS are equal. The obtained expression, the required expression are same. So in this way, you can determine the inputs for the given output expression. Okay, let's see another model. What is the required input condition a comma b comma c to make the output x is equals to 1 for the below logic circuit? Here also the same. They are expecting the output to be 1. What are the input combinations? What might be the a value, b value, c value? That's it. Now guys, here as per the design, what is the expression here? It is an XOR gate. Therefore, it is a XOR b. Similarly here, B, C, it is XNOR gate. Therefore, B XNOR C and it is C. Therefore, the actual expression for X is equals to A XOR B into B XNOR C into C because it is AND gate. Now, here, what is B XNOR C? BC plus B bar C bar, XNOR expression. Therefore, here it can be like BC plus B bar C bar. Again guys, C. Now, if you multiply, what we get? BC into C, BC. C bar into C, 0. Then it is A bar B plus AB bar, the XR output expression into BC. Hence again here guys, A bar BC, A bar BC, again B into B bar, 0, then it is A bar BC. So the output expression is A bar BC. Now here, if A is equals to 0, so that 0 bar, 1, B as 1, C as 1, then obviously output will be 1. For this condition only, for this combination only, output will be 1. This is method 1. Yes, the regular approach. However guys, to optimize the time, to save the time, we have another method. That is very simple. In fraction of seconds, we will get it. Let's see. Now, guys, output to be 1. then for a AND gate, all the inputs must be 1, right? Then only I will get 1, no? Right. So C as 1. For this XNOR gate, for whenever the input combinations are same, then only output will be 1, no? For 0, 0 combination or 1, 1 combination, you will get the output as 1. But here C must be 1, then obviously B must be 1. Then only B XNOR C will be 1. Now, guys, here, this is XOR gate, this is XNOR gate. Obviously, for the different input combinations, output will be 1. Hence, here A value must be 0. Therefore, A0, B1. You will get output as 1. 1, 1, output as 1. 1 anyway. In this way also, you can tell the input combinations for a given output. Remember guys, for every problem in life, in the design simplification, there will be multiple solutions. Which solution you have considered is you only. Okay guys, this is about like the determination of input combinations for a given output. Hope you like the video. See you in the next video. This is Shivaram signing off. Jai Hind.